In this class, the orthographic projection concepts we are going to discuss as basics. So this is unit number 2, and in this unit, in the manner of orthographic projections, we are going to study, or we are going to learn how to draw the projections of the elements, points, straight lines and planes. Okay. First we have to be clear with what is orthographic projections and why it is important in engineering graphics. What is actually the concept of projecting the object? So by the operation projecting, what is our outcome? What we are going to get after projecting an object? So this is what the basic task in this. See, in engineering graphics, not like our conventional drawing, we are going to draw the objects blindly in the paper. Here we are going to draw the views of the object. The actual object is there. That actual object is going to be projected in imaginary screens or imaginary planes. The projections will give you the views of the object. That views going to be drawn by you in the paper. This is nothing but the engineering graphics first angle projection. Here we are going to assume two principal planes. You know about what is a plane. Plane is a plane surface. Okay, we are going to assume two principal planes, say just like a screen. Okay, in that planes we are going to deposit the view of the object, just like the shadow. So that view is going to be drawn by the student in the paper. See here. See, it is a plane. It is a plane, just like the floor, in our home. And this is also a plane, just like the wall in our home. Okay. What is the inclination between the floor and wall in our home? It is 90 degree. So the floor and wall are mutually perpendicular to each other. Okay. And in our engineering graphics concern, we are going to assume two planes, horizontal plane and vertical plane. These two planes are considered as the principal planes. By using these two planes only, we are going to develop the views of the object by projecting the object. See, these two planes are called as VP, that is vertical plane, and that one is HP, that is horizontal plane. Based on their nature of arrangement, we named them as horizontal plane and vertical plane. Okay. These two planes are stand for getting the views of the object. For example, if you want to project any object, you have to place or you have to assume the object with respect to the horizontal plane and vertical plane. If I am assuming an object here, if I am assuming an object here, then I can get the two views of the object. So what is the action of projecting an object? Projecting an object is nothing but just making the view of the object in the screen as a 2D view. It's very similar to projecting a light beam towards an object. For example, if I am having an object here and this is the wall or the screen, if I project a light in front of that, what I will get in the screen? The shadow of the object. This shadow is nothing but considered as the view of the object here. The shadow is having no features. Only the outermost boundary of the object can be viewed. But the view of the object is completely different from the shadow. For example, if you are going to project an object which is having a shape here, if you project it in the screen, you can get the exact shapes of the object in the screen. If you just have the shadow of that object, only the outermost boundary can be viewed. This is shadow. This is shadow, and that is nothing but view. So it is not possible to get the view in the practical. So these everything are imaginary only. They are just illusions. In our imagination, we are preparing these views just by projecting the object towards the screen. So when you just project a light in front of the object, only you will get the shadow. Only you will get the shadow of the object in the wall. It is nature, it is the fact. But in our engineering graphics concern, we are not going to get the shadow. We are going to get the view of the object. What actually here you are seeing, this will be appeared here also. This is nothing but the difference between getting a shadow and getting a view. Here we are going to get the view only, not the shadow. So the same way you can project the object from the top. If you project the object from the top, you will get the view here in the horizontal plane. In the horizontal plane, this view here, what you are going to see is what you are having the object in this surface, which is possible to see from the top, will obtained in this view. So this is nothing but the two views of the object. This is obtained by seeing or projecting the object from the front. So this view is called as front view. That view is obtained by projecting the object from the top. So this view is termed as top view of the object. In the same way, side view is also there, but we are not going to discuss about the side view now. Now you can concentrate more on the front and the top views. So the front view and the top views are nothing but just the views of the object. These are all not object. They are just views of the object. The original object is this one. This one is nothing but the original object, and this one and that one are just views of the object. Our objective in engineering graphics is to draw the views of the object. In this chapter, we are not going to draw the three-dimensional view of the object. You are going to draw only the two-dimensional views of the object, which is obtained in the vertical plane and the horizontal plane. Okay, where I need to place the vertical plane and the horizontal plane, what is the color of the plane, what is the dimension of the plane, you need not to worry about that, because these everything you are going to have in your mind only. We are not going to place the vertical plane and horizontal plane in practical, in our room or in our classroom or somewhere else. The horizontal plane and the vertical plane should be placed in our brain. Inside our brain, we are going to have these two planes, and the object you are going to draw should be placed against this horizontal plane and vertical plane based on the instructions given in the question. So based on the distance of the object with respect to the horizontal plane and the vertical plane, you are going to place the object, and after placing the object in that position, you are going to project the object from front side and the top side in order to get the front view and the top view respectively. So this is nothing but the concept of projection to get the views of the object, that is to get the front and top views of the object. And the front and vertical plane and horizontal plane, already I have told these two are the imaginary planes, and the arrangement of the planes are like that only. These two planes are mutually perpendicular to each other, just like your wall and floor in your home, in your room. In your room you are having the floor and wall. So this is considered as your floor and that's considered as your wall. And we can have the front side and the back side of these planes also. See here. The vertical plane can extend below the horizontal plane also. The vertical plane can extend below the horizontal plane also, and the horizontal plane can extend behind the vertical plane also. Okay, behind the vertical plane also. So this is vertical plane and this is horizontal plane. These two planes are intersect with each other, and this line is nothing but the line obtained by the intersection of these two planes. Intersection of these two planes. So based on the position of the object, you can say the quadrant where the object is placed. See, this environment is created by the presence of the horizontal plane and the vertical plane, and this space is nothing but above horizontal plane and in front of vertical plane. This is nothing but this space. This space is termed as quadrant 1 or first quadrant, and that space, that is above the horizontal plane and behind the vertical plane, that space is termed as quadrant 2 or second quadrant, and this space, the space below horizontal plane and behind vertical plane, is termed as third quadrant, and that space just below the horizontal plane and in front of the vertical plane is termed as fourth quadrant. If you have the view in that way, this is the vertical plane and that is the horizontal plane. Just if you look this environment in this direction, you can have the vertical plane and horizontal plane just look like a line, and this is nothing but first quadrant, second quadrant, third quadrant and fourth quadrant. First quadrant nature is the space is nothing but above HP in front of VP. So this is your vertical plane and that's your horizontal plane. Okay. So this space is nothing but above horizontal plane and in front of vertical plane. In front of vertical plane, and that space is nothing but above horizontal plane and behind vertical plane. Okay, behind vertical plane, and in the third quadrant, it is nothing but below horizontal plane. Okay, so this is horizontal plane, the space below horizontal plane and behind vertical plane. Behind vertical plane, and the fourth quadrant is below horizontal plane and in front of vertical plane. So in this way you can have the four quadrants where the object is going to be placed is the matter in every question. The object can be placed in the first quadrant or in second quadrant, in third quadrant or fourth quadrant. In any quadrant you can place the object, and why we are placing the object against the horizontal plane and vertical plane, in order to get the views of the object. So as per the engineering graphics concern, by the orthographic projection concept, you need to consider your object against the horizontal plane and vertical plane. Then only you will get the front and the top views of the object. So the requirement here is you have to draw the front and top views. In order to draw the front and top views, first you need to get the front and top views. By using the horizontal plane and vertical plane only, you can project and get the front and top views. So for all this purpose only, we are imagining the horizontal plane and vertical plane, and the object's views will be obtained by using the orthographic projection concept. In real world, there is no horizontal plane and vertical plane. For our academic purpose only, we are considering this horizontal plane and vertical plane. And orthographic projection concept is nothing like that. This one is orthographic projection concept. The word itself having its meaning. Ortho means 90 degree or perpendicular. Graphic concept is obtaining the views. See here, in order to get the front view of the object, you have to see the object perfectly perpendicular to the vertical plane. Perfectly perpendicular. Your visual rays should be perpendicular to the vertical plane. Then only you will get the front view of the object in the vertical plane. See, we are seeing the object in order to get the view in the vertical plane. The obtained view here is nothing but front view. In order to get the top view, you have to see the object from the top, and that time your visual rays should be perpendicular to the horizontal plane. You need to see the object from the top and your visual rays are perpendicular to the horizontal plane. Then you will get the top view of the object in the horizontal plane. This is nothing but the top view. So because of the angularity relation between your visual rays and the principal plane is 90 degree, this concept of projection is called as orthographic projection. Okay, sorry. In that way only we are going to draw the front and top views of the object in the next chapter. This is the core concept of our engineering graphics subject. For the rest of all the units, this is the concept. So only unit by unit, the objects may differ, the activities may differ, but the orthographic projection concept is the same for the rest of all 4 units. For total engineering graphics, this is nothing but the theme. Okay. Let me rub up the board. Maybe you have some doubt. So these things are okay. Front view, top view, horizontal plane, vertical plane. How to draw them in the paper? What to draw in the paper? Whether I need to draw the horizontal plane and vertical plane in the paper just like in the board? So these questions may be with you. So time by time I will explain the things. What actually you are going to draw in the paper, what actually you are going to imagine in your brain. So everything are different. In engineering graphics, particularly in the orthographic concept, 50% of the work has to be done with your brain itself. And only the 50% of the remaining work need to be done in the paper. So both are important. Without imagination, without thinking, nothing you can draw in the paper. Okay. And a very important point here is there is nothing to memorize. You need not to memorize any formula or equation or derivation, anything else. You need not to memorize anything. Engineering graphics actually an art. You are going to practice. You have to practice the engineering graphics and you have to use it for the on-hand situation. There you need not to memorize anything. There is no formula or equation needed to memorize it and use it for the given data and finding out the answer, deriving the things, nothing like that here. You are going to learn the art. You are going to use it for the particular situation, for making the output. So this is what the nature of work in engineering graphics. For that you have to learn the art, engineering graphics, and practice it by your own in the paper with proper tools. Then you can be a master in engineering graphics. Okay. Just we discussed what is horizontal plane, what is vertical plane, and what is front view and what is top view. Okay. Just after that, what you are going to draw? You are going to draw objects starting from scratch up to 3-dimensional object. So this is what the thing. And here the objects are arranged in a better manner, starting from the no dimensional object up to 3-dimensional object. See, no dimension or no dimensional object, 1-dimensional object, two-dimensional object, and finally 3-dimensional object. So objects here we grouped in 4 points: no dimension, 1 dimension, 2 dimension and 3 dimension. So in that, what is actually no dimension? If there is nothing to measure, then how can be an object is present in the world? Any lead in that? What can be a no dimensional object? Yes. Yes, who is that? Yes, points. Points are nothing but no dimensional object. There is no length, breadth, height, width, volume, weight for a point. Point is having no dimension. You can't say a point is a straight point. You can't say a point is a round point, a hexagonal point, a pentagonal point. There is no shape, particular shape and size for a point. Point is a no dimensional object. Okay. And who can be a 1-dimensional object? That is 1D, the straight line. The straight line. A straight line can be a one-dimensional object. You can measure the length for a straight line, but it is not possible to have the breadth, thickness, width or height for a straight line. Just you can measure its length. This is nothing but the length of a line. So only one dimension. This object is having only one dimension. This object is called as one-dimensional object or 1D object. And who can be a two-dimensional object? So just let me to mention its name. So one-dimensional object is nothing but points. Two-dimensional object is nothing but straight lines. And one-dimensional object is nothing but straight lines. And two-dimensional objects are nothing but planes. Planes. See, what is it actually? A rectangle. A rectangle. For this rectangle, you can measure the length and breadth, or length or width, whatever it may be. But you can measure two dimensions for this object. So planes are two-dimensional. Not only the rectangular plane, the square plane, pentagonal plane, hexagonal plane, even circle is also a plane object. They are called as two-dimensional object. They are having the dimension can be measured in two principal axes. That is, in x and y axis, you can measure their dimension. In x and y axis, you can measure this much unit in x axis, that much unit in y axis. In this way, you can measure their dimension in two principal axes. They are nothing but 2D objects, two-dimensional objects. And what is three-dimensional objects? The objects which are all having dimension in all three principal axes. Totally in this world, we are having maximum three dimensions only. For the entertainment purpose, maybe in the theaters they are mentioning that 7D sound and 8D sound, whatever it may be. But as per the mathematics, only three axes are there principally. X-axis, Y-axis and Z-axis. Okay. So the object, simply solids are the three-dimensional objects. Solids are the three-dimensional object. You can measure the length of the object in one axis, the height of the axis is, object in another axis, and the breadth of the object in some other axis. See, in all x, y and z axis, you are having dimensions for this object. This object is nothing but solids, which are all termed as three-dimensional objects. So in our engineering graphics, we are going to draw the front and top views. That is, we are going to project and obtain the views for all this no dimension, single dimension, two dimension and three dimensional objects in each chapter. In this second unit, we are going to draw the front and top views, or we are going to deal with the projections of points, straight lines and planes. In the next unit, we are going to deal with the solids, and then in the next chapter, sections of solids, development of surfaces, isometric projection, freehand sketching, these things will goes on. But the core concept behind all this unit is only orthographic projection. This is what we are going to practice in our engineering graphics. But engineering graphics is not limited with these 5 units. Engineering graphics is an ocean. Lot of things are there to study in engineering graphics. For our academic purpose, we are scheduled to study these things only in this semester. Okay.